Hello, a very warm good evening to all of you, and welcome to Unacademy. Welcome to today's session about tropical cyclones. Now, tropical cyclones are some of the most devastating and destructive weather phenomena that you experience anywhere across the world, be it in terms of the destruction, the loss of life, the loss of property, the amount of rainfall, the wind, energy which is generated by them. Tropical cyclones end up being quite devastating. Now, every year, India does experience a lot of these tropical cyclones, but not only India. The entirety of the region of South Asia does experience a huge amount of these tropical cyclones. In this session, we are going to understand what these cyclones or how these cyclones are created from the very basics. What is their overall impact? And also, which are the regions across the world where you have the impact of these tropical cyclones? We will also take a look at the factors, the geographical factors associated with the annual flooding caused by these tropical cyclones. Also, how do these cyclones get their names? What is the factor behind the naming? You would have heard about the cyclone Montha, the cyclone Biparjoy, etc. How does that naming come into place? So, those are the details that we are going to cover in today's particular session. Here, we are also going to understand the basic reasoning associated not only with the formation, but also when it comes to the case of their movement, the overall progress. So, first of all, before we initiate the discussion, an announcement for everyone. Now, if you want to get better in geography, the basics of geography and the basics of mapping as well, from tomorrow, 5 p.m., Monday, Wednesday, and Friday, we are going to have free classes of geography for the geographical map. Tomorrow, we are going to start with the mapping of the portion of Europe. Okay, that is what we are going to cover from tomorrow. And eventually, we will move through all the different continents. So, join us tomorrow at 5 p.m. on the app. You can scan this and you can directly enroll for the session. You can follow my name in the app as well. Thereby, you will get the notification whenever next sessions of mapping will happen. You will get that notification. The political map, the physical map, the mountain systems, everything will be covered in this in great detail. Now, another announcement for everyone preparing for civil services. We have come up with a very lucrative offer. 16,999 is the price at which we are offering the entire course of GS plus CSAT along with the test series. But it is not only the aspect of the pricing, along with that, you have the free extension beyond 12 months. You need to use the code IAS English. The offer ends tomorrow. Do not delay and ensure that you prepare at the earnest. Now, having said that, which is the chapter of NCERT that we are referring to? We are referring to the chapter 9, that is atmospheric circulation and the wind systems. Now, in this chapter, we had discussed about the weather phenomena, that is the wind patterns, the pressure systems, the pressure belts, which get created. Along with that, we have also discussed the case of the temperate cyclone, air masses, the frontal formation, the weather climate associated with each of the frontal formation, the movement and the formation of the temperate cyclone, everything we have managed to discuss in greater detail. Now, here we will start the discussion of the tropical cyclones. Now, when we say the tropical cyclones, first of all, cyclones are what? Cyclones are regions of intense low pressure, isn't it? These are regions of intense low pressure, right? Now, these intense low pressure will attract winds from all different directions, and thereby a cyclonic circulation, that is, a circular movement of air, will be generated. And here, the basic aspect again that you have to keep in mind, that winds always blow from a high to a region of a low. Now, in this case of intense low pressure, how does this low pressure get generated, by the way? In yesterday's session, we had covered the fact that the low pressure in the case of a tropical cyclone is generated how? The low pressure is actually a thermal low pressure, isn't it? It is a thermal low pressure. That means what? That means this low pressure is generated because of the heating caused by solar insolation, by solar energy. Okay? The heating which is caused and created by the solar energy. Now, this heating which is created by solar energy, think about it. Where across the planet Earth will you have highest amount of heating? At the lower latitude between the Tropic of Cancer in the north and Tropic of Capricorn in the south. That is where you will have the highest and you will receive the highest amount of heating. So, the region where you will experience these tropical cyclones is between Tropic of Cancer and the Tropic of Capricorn. And hence the name tropics and the tropical cyclone. Okay. It is not only experienced in India, it is a global phenomena, but it is named by different properties across the world. So, here, what are these cyclones? These are violent storms that originate over the oceans in the tropical areas, and they are known as cyclones in the Indian Ocean, hurricanes in the Atlantic, typhoons in the Western Pacific and the South China Sea, and willy-willies when they occur in the region of northern Australia. So, this is the global distribution. All of this is nothing but the case of a tropical cyclone. It is not a different phenomenon. So, hurricane and a cyclone and a typhoon and a willy-willy is absolutely the same. Okay, all of those are absolutely one and the same phenomena. It is the naming which is different. So here, in each of the region, it is named differently. For example, in the region of Arabian Sea and Bay of Bengal, simply known as a cyclone. In the region of northern Australia, willy willy. In the region of east western Pacific, South China Sea, etc., typhoons. So typhoons will hit the region of Philippines, Chinese coastline, Vietnam, Thailand. They are impacted by typhoons. In the region around the Americas, that is the region around North America, they will be known by the name hurricanes. Okay. So that is where you hear about the term. For example, you have various hurricanes, Hurricane Alpha, Hurricane Beta, Hurricane Gamma, Theta, all of them, they are the property associated with the region of Americas. But one and more or less the same phenomena. Now let us understand the process of formation here. But before I delve into the detail about the process of formation, basic aspect of science requires to be visited or revisited so that you understand the detailed concept. And which is the concept of science that I'm referring to? I am referring to the concept associated, which is known as the latent heat of condensation. Hurricane and tornado are same. No, tornado is different. Tornado is a very different phenomena. Hurricane, typhoon, cyclone, willy willies, they are the same phenomena. Tornadoes are created because of a complicated mixture of the frontal formation along with the thermal heating, where you do actually experience a circular movement of air and the entire thing gets uplifted because of the convection current on the ground. Tornadoes are experienced in this portion of US. That is in the region around Gulf of Mexico, in the Great Plains of US. This is where you will experience tornadoes. Okay. Which cyclone will affect habitat temperature? Temperate habitat, temperate cyclone or tropical cyclone? Tropical cyclone and temperate cyclone, both of them can have devastating impact. But when it comes to greater amount of destruction, more wind speed, higher wind speed, more energy carried, it is always the case of tropical cyclone, which is more devastating. Always. Okay. And that is basically because of the properties that we are going to study right now. Okay. So now let us start with the basic aspect of the latent heat of condensation. Now, you would have studied that in your elementary classes of science about latent heat. What is this latent heat? So basically, water does exist in three different states, isn't it? In the solid state, you have the presence of ice, right? In the liquid state, you have the presence of water. And then in the gaseous state, you have the presence of vapor, right? In three different states, water does exist. Now, when you basically want to convert ice to water, you provide heating, right? Again, you provide heating when you want to convert water into steam or vapor, isn't it? But then, when you provide that heat, some amount of energy is consumed in raising the temperature. For example, at minus 5 degrees Celsius, also you will have ice. And listen to this very carefully. It is a simple concept. You will be able to understand this. At minus 5 degrees Celsius, also you will have the presence of ice. At minus 4 degrees Celsius, also you will have the formation of ice. At minus 1 degree Celsius, also you will have the presence of ice. At 0 degrees Celsius, also you will have the presence of ice, right? But as you raise the temperature, as you provide more heat to that ice, its temperature will increase from minus 5 to maybe 0. At 0 degrees Celsius, when you provide that heat, some amount of that heat will be consumed by the ice in order to break these bonds that they have. After all, any solid state will have multiple bonds holding the solid together. So that heat will be consumed by ice in order to get converted to water. After that, you provide heat, water will get heated from 1 degree, 2 degree, 3 degree, 4 degrees Celsius, and so on. The temperature will increase. Again, when the temperature reaches 100 degrees Celsius, some amount of heat will be consumed by the water to break the bonds to get converted into vapor without indicating any rise in temperature. So, this heat, which is consumed without indicating an increase in the thermometer, that is what is latent heat. So, latent heat is what? Latent heat is basically the heat consumed, right, for change of state, change or even released for change of state without an increase in temperature. I hope this is clear. What is this? Without an increase in temperature. Okay. So when you convert or when you start heating ice, it will get converted into, first of all, water, then it will get converted into gas. So observe this image carefully. Observe this graph very carefully, right? Let's suppose you have ice at a negative temperature. X axis provides you the amount of heat. Y-axis indicates the temperature rise. Initially, when you provide heat, the temperature does increase. It reaches 0. After that, when you provide heat, temperature does not increase. This heat is consumed to change the state. Again, as you provide heat, temperature increases from 0 to 100. Again, as you provide heat, temperature doesn't increase, but that heat is consumed to change the state, right? Now, the converse of it is also true, which means what? Which basically means if, let's suppose, vapor is cooled down. After that, cooling means what? We have discussed about the fact that cooling in itself is not a form of energy. Cooling is extraction of heat energy. That is it. For example, if I have a utensil, I keep it in a refrigerator. How does that utensil cool down? The refrigerator extracts the heat energy out of it. So basically, and releases that heat energy. Only then the utensil will have its temperature dropping. So when you have water in the vapor state, in that particular case, if you cool down, that is extract heat energy, its temperature will drop. But before converting and while converting from vapor to liquid, it will release some amount of heat without cooling down, just for the change of state. So, a conclusion in simple terms: vapor, whenever it undergoes condensation to liquid, releases heat energy, releases heat energy, and this heat energy is what is known as latent heat of condensation. Is it understood? Now, you might be thinking, first of all, geography in itself is so tough. Why is it that this individual is telling me all the detail about latent heat of condensation? I wanted to study about tropical cyclone. I wanted to know cyclone Mantha, cyclone Arnab, and so on. Why is this latent heat of condensation coming into the picture? The answer is very simple, guys. The entire process of formation and intensification of a tropical cyclone is closely associated with the release of latent heat of condensation. The release of latent heat of condensation ensures that the tropical cyclone gets stronger. And it is this factor which is also associated with the weakening and eventual dissipation or the death of the tropical cyclone. That is why, for the tropical cyclone, this factor becomes absolutely important. Now, once you have understood this, let us understand the basics about the formation of a tropical cyclone. What are the processes involved in the entire formation of a tropical cyclone? So, first of all, tropical cyclone will only get created over large water bodies. And by large water bodies, I do not mean that, sir, I have a pond, a large pond in my backyard. People say it is the best pond in Asia. People say it is the largest lake in the world. So, will the cyclone be created there? No. When we say water bodies in the case of geography, always serious geography, whenever we talk about water bodies, we refer to oceans and seas of the world. Okay. So, always a tropical cyclone will get created over large water bodies. Large water bodies only, not over the land area. Keep that in mind. Now, so let's assume you have the case of a large water body. See, we are starting from the very scratch. Pay attention for the next 10 minutes after the session. When you are done with the session, after that, take a piece of paper and try to write down whatever you retain. Those notes will be more valuable than gold for you. So please use that in order to enhance, in order to understand the and revise the case of the tropical cyclones also. So let's suppose you have a large water body. Now, this cyclone is created why? Because of heating, temperature increase. So let's suppose there is heating. The heating has increased the temperature beyond 27, 28 degrees Celsius. Why only 27, 28 degrees Celsius? Why not 35, 37 degrees Celsius? Why not 40 degrees Celsius? Why not 20 degrees Celsius? So, in the tropics, the water bodies on an average indicate a temperature of around 24 to 25 or 23 to 24 degrees Celsius, depending upon the region, depending upon the season also. When you have the temperature which increases beyond 27, that is when a low pressure starts to get created. And low pressure formation, thermal low pressure formation, is essential for the germination or the generation of this particular cyclone. So here, when that heating does happen, it creates a low pressure, right? It creates a low pressure. Low pressure means what? It will attract winds from all different sides. After all, winds always blow from a high to a low. So here, the winds will basically start getting attracted. And by the way, sometimes the temperature even breaches the 30-degree mark. For example, in the recent past few years, both Bay of Bengal and Arabian Sea in the month of May and June have indicated a temperature of as high as 33 to 34 degrees Celsius, which is immense, very, very high when you consider the water bodies. Land areas obviously can get heated to 40 degree, 45, 47, 48 degrees Celsius. But water bodies indicating that high temperature beyond 30 is very devastating and can create cyclone, can create bleaching of the corals, can create mass extinctions in the seas and oceans. Now here, the winds, they come from all directions. They are attracted to the low pressure. Now, for these winds, what is the property that I know about these winds? For any air mass, we have discussed yesterday that there are two properties for any air mass. One is that of temperature, second is that of moisture content, isn't it? Temperature and moisture content. So, what is the property of this air mass which is coming to the low pressure? One is the case of it will be warm and very moist. Why very moist? It is coming from the oceans, from the water bodies. So it will be picking up moisture along the way. It comes to the region of low pressure. Coriolis force will be acting upon it. So it will start rising up. But the rise will be in a spiral manner because of the Coriolis force. The rise won't be in a straight fashion. It will be a spiral fashion, isn't it? Now, this rise will happen up till what extent? Up till the region of the sun, up till the region of ionosphere, thermosphere. Till when will the air rise? The air will be rising up till the region of tropopause. Beyond tropopause, there is a temperature inversion, so air won't go into the region of stratosphere. So here, it will basically rise like this, isn't it? And like that, the air will rise. Now, once the air rises, rise of air, why will it rise in a spiral fashion? Because of the impact of Coriolis force. Remember, we had discussed yesterday that how the cyclonic circulation happens to be in a in an anti-clockwise direction in the northern hemisphere and a clockwise direction in the southern hemisphere because of the Coriolis force. Winds which are being attracted, those winds deviate to the right in the northern hemisphere, and the same winds deviate to the left in the southern hemisphere. So that is why it is not going to be a straightforward rise, it is going to be a spiral rise associated with the case of the Coriolis force. I hope that is clear. Now, rise of air. When the air rises, what happens to the temperature of this air? Temperature will fall, it will cool down, isn't it? As it cools down, there will be condensation which will happen. It will undergo condensation. Yes. So there will be condensation which will naturally occur in this particular case. Now, this condensation means what? Cloud formation. Now, where will the cloud formation happen? Wherever the air is rising, or in general, everywhere. Condensation will only happen wherever the warm air is rising and is cooling down. So if I ask you, of the two places, that is, of the two places, this one and two, where will the condensation happen? It will happen in the case of two, which is in the pathway of the rise of air, isn't it? So here, the condensation begins to occur all along the sides. All along the sides, the condensation will begin to occur. Right? And this condensation, when it occurs across the sides, because that is how the air is rising. And if the air is rising here, condensation will happen in this point. It will not happen in the center just because the air is circulating around. So it is in the pathway of the air that the condensation will happen. Now, this condensation will lead to formation of very dense clouds. It will be circular clouds, but obviously in a two-dimensional diagram, it will appear to look somewhat like this. Okay, but it will be a kind of a circular cloud formation. Now, whenever this condensation does occur, remember, condensation releases heat. That is the latent heat of condensation. So here, heat will be released here in the form of latent heat of condensation in the central portion. In the central portion, heat will be released in the form of latent heat of condensation. All that heat will accumulate in the central portion because all around the central portion, clouds are getting created all around the central portion. But in the central portion, heat will be accumulated. Now, when heat gets accumulated, when the temperature increases, will condensation happen? No. For condensation to happen, cooling is required. So, in the central portion, because of this accumulated heat, no cloud formation. So, that is why the central portion is quite free from the case of cloud formation. Okay. Now, at this stage, I want you to recall your childhood mischief. Many of you would have done this in your childhood days. That is, you would have seen a bucket of water, right? And that bucket of water basically filled to the brim. And with your hands or with your entire fist, you would have tried to create your own whirlpool, right? I'm sure many of you would have done that. If you have never done that, try to do that. Even today, it is never too late. Now, whenever you would have done this, what is it that you would have experienced? That water starts rising up on the sides. Some of that water even spills out. The faster that you move, greater is the spin and the rotation, and more the water rises up and more the water spills out. All of you would have seen that. But what do you observe in the central portion? In the central portion, you observe a depression, isn't it? A kind of a suction is created because of the rising sides. As the sides create that vortex at a very high speed, central portion experiences a suction. Now implement this in this image. On the sides, you have rising air. So what will happen to the central portion? The air from the surrounding will be experiencing a kind of a suction, isn't it? So in the central portion, you will have sinking air column, sinking air. Now, sinking air, we have done this previously, this basic concept. Sinking air leads to what? It is being pushed to the region of high air density. Sinking air gets compressed, adiabatic compression, isn't it? It will get compressed. As it gets compressed, there will be heating, temperature will increase in this particular case, right? So, this air will get more warmer, right? So, what will happen to the temperature in the central portion? What will happen to the temperature? Temperature will further increase. Why? Because of two reasons. One is latent heat of condensation, which is released in the center, and the second portion is sinking air, isn't it? These two factors will further increase the temperature. Now, when the temperature increases, what will happen to the intensity of this low pressure? This low pressure gets more intense because the temperature has now increased as compared to earlier. This is a thermal low pressure that we are talking about. So, in this particular case, gets more intense. When the low pressure gets more intense, let's suppose it was earlier 990 millibar. Now the temperature has increased by 4 degrees Celsius or 2 degrees Celsius. It becomes 970 or 950 millibar. Means what? It means it will attract large number of winds. More winds are attracted, isn't it? Now, these more number of winds which get attracted, they are also the warm and moist winds. They will also start rising up across the same spiral. As they rise up across the spiral, they also undergo the process of condensation. They will also form clouds. But what about the already existing clouds? What will happen to them? Those clouds will simply be pushed to the sides. So, what you will have is basically the newer formation of clouds with the older ones getting pushed to the sides. Like this, the circular formation of clouds keeps on increasing and the size of the cyclone keeps on increasing. So, here what is happening? More condensation is happening because more winds are coming, means more latent heat, more temperature at the center, intensification of low pressure, more winds are attracted. Like this, the low pressure keeps on intensifying itself. That is why oftentimes this cyclone is also what is referred to as a heat engine. Heat engine, because it is able to generate sufficient amount of heat on its own to sustain its formation and to keep on intensifying itself time and time again. Okay. Now, in this particular case, understand this. I will give you the entire thing in writing as well. So, why is it referred to as a heat engine? First of all, low pressure attracts, just like yesterday, we had a kind of a flow chart for the intensification of a cyclone. This flow chart is also equally important. Attracts warm and moist winds. Moist winds, they rise up, winds get heated. Nothing will happen without a pressure gradient force. Whenever you have a low pressure, means a pressure gradient force is there. What is pressure gradient? Difference of pressure. So, in between any two places, if at all a wind is moving, it is because of the pressure difference. So, whenever we say a low pressure, means what? It is lower than the surrounding. That means there is a pressure gradient in place. That is why the winds are getting attracted. Okay. Now, here winds get attracted, right? Or winds, after they are attracted, they get heated at the region of the low pressure. They rise up. As they rise up, then condensation occurs. Whenever condensation occurs, that means latent heat is released. As the latent heat is released, means what? Temperature in the center. The sinking air does not eventually hit the surface. Uh, Kunal, okay, Kunal Shivante, the sinking air does not hit the surface. Observe here. That is why I gave you the bucket example. Here, does this depression sink beyond a particular point? No. It will have a depression, but not beyond a particular point. So that is why the sinking air will not hit the surface to create a high pressure. But nonetheless, it will compress the air to generate heat adiabatically. Okay. So temperature increases, center increases. As the temperature in the center increases, what happens? Self intensification of low pressure. Now, this will basically attract more winds, and it repeats itself. As a result of this entire cycle, what is happening? Temperature keeps on rising. Low pressure keeps on, keeps getting more intense, isn't it? As this keeps on getting more intense, then winds continue to get stronger, right? That is why, as long as this tropical cyclone is present and persistent, the longer the duration, stronger it gets. Okay. But here, in this entire process, I hope everyone is able to understand one of the key factors here, that condensation and latent heat is a key factor in self intensification of the cyclone. What if this condensation stops? Then what? Then this entire chain will be broken. Then the further intensification won't happen. There lies the key for the weakening and the dissipation of the cyclone. When does the cyclone die? Till when does the cyclone remain active? And when does the cyclone eventually die? So that is where we will take a look into it. But this is the schematic representation of the cyclone. So here you will observe that you have the intense low pressure in this region. Okay. Intense low pressure in this region. Okay. Rise of air in a spiral, it moves outwards, and observe these individual older clouds being pushed to the sides. These are known as rain bands. Okay, this entire circular formation is known as the rain bands. So here, what you observe in the central portion is a complete lack of any cloud formation. Why? Because the temperature is high. This is known as eye of the cyclone, of the cyclone. Okay, because it doesn't have any cloud formation because of higher temperature. On the sides, however, the cloud is very dense, maybe around 10 kilometers to 12 kilometers in thickness. This is what is referred to as an eye wall. That is what is referred to as the eye wall of the cyclone. Okay, so here let us take a look at it with the help of animation as well. And then we will be able to understand the dissipation. So, this is the region which is your eye. So, eye basically means no cloud cover, no clouds, clear sky. Why? Because you have high temperature and sinking air. At higher temperature, condensation can't happen, right? High temperature and sinking air. Okay. And the eye wall, as you can see here, very, very dense cloud formations are there. Here also you can see the kind of movement, isn't it? Circular movement, all because of the Coriolis force. Now, when does the cyclone eventually dissipate? This is the image of a hurricane, satellite image of a hurricane. In this hurricane, you can very clearly and visibly see the eye. In the initial stage of the hurricane, observe when this is your land area. It is being formed in the region of Gulf of Mexico, by the way. So, this is the region of your Gulf of Mexico. Gulf of Mexico. Observe here that as long as it is over Gulf of Mexico, observe how substantial the eye looks. Absolute no cloud formation. How strong the cyclone looks. The moment it hits the land, that is when it starts to weaken. It gets diluted, the strength reduces, and eventually it dissipates. So, when does a cyclone make a landfall? What is known as the landfall of the cyclone? So, if you consider this entire formation, let's suppose this is a land area, and let's suppose this is the water body. Tarak, those are not necessarily the stages of cyclone. That is the classification of cyclone based upon the speed that you have. I will show you the chart also. What is referred at which wind velocity it is known as a depression at wind velocity of more than 220 kilometer per hour. For example, it is known as a super cyclone. So it is not necessarily the stage of formation because not every cyclone will develop into a super cyclone. It depends upon the strength of the low pressure. I will show it to you. Okay. Now, if let's suppose here I have the entire circular cloud formation. Okay. I have the entire cloud formation here. Now, initially, when this hits the land, it will cause huge amount of rainfall, very strong winds, gusty winds, huge amount of rainfall, right? But then the eye comes over. When the eye comes over the land, people on the land who were impacted by the heavy rainfall, they will get a view of the clear sky. Sun will start appearing once again, even though for a brief duration, but the sun reappears. Many people mistake it that the cyclone has ended, but in reality, that is not the case because that is just the eye present over there for some duration. After that, other portion of the cyclone again hits the region with the strong winds and rainfall. So when the eye comes over to the land, comes over the land, right? That is what is referred to as landfall of the cyclone. Clear? Now, the moment it comes over to the land, let's suppose it has come over to the land area. Then what? Now, this will keep on attracting winds. But these winds which are coming here, will they have moisture? No, these will be continental winds. So after landfall, I can be few kilometers wide, 2 kilometers to 5 kilometers sometimes, even in certain cases, 10 kilometers and beyond. That can be the diameter of the eye. Landfall, after landfall, winds are attracted, right? But these winds, they will lack moisture. They lack moisture. So that means no condensation, because for condensation to happen, you need moisture. Means no latent heat. If you don't have latent heat, means no intensification of low pressure, right? So whatever the existing clouds are there, they will cause rainfall and it will die off. No further cloud formation will happen. This is known as the case of the cyclone's dissipation. So cyclone will dissipate after landfall. After landfall. Okay. However, I hope till here everyone is very, very clear. Everyone has understood the concept in great detail. Now, in certain cases, for example, it has happened once or twice in our country as well. Let's suppose before the cyclone makes the landfall, prior to that, if the region has received lot of rainfall already in the past 2 to 3 weeks, there will be lot of moisture on the ground. The soil will be damp, there will be water accumulated everywhere. So in that case, when the cyclone hits that land, the moisture will be further provided. So in rare cases, you can have the situation where even after making landfall, the cyclone can re-intensify. But that will only be very, very rare when the region would already have received sufficient rainfall prior to the cyclone hitting the region. You have had two such instances in India. One where a cyclone in Arabian Sea hit the region of Gujarat coastline. This was Cyclone Tote. Cyclone Tote. Okay, around 4 years ago. And even prior to that, around 6 to 7 years ago, you basically had a cyclone hitting the region of Odisha. That was Cyclone Titli. These were the cyclones which managed to re intensify themselves after making landfall because the land had enough moisture. Otherwise, cyclone will always weaken and will dissipate. Now, necessary conditions for the cyclone formation. Not every low pressure will create a cyclone. What are the necessary conditions? First of all, there has to be large sea surface with temperature higher than 27 degrees Celsius. Why only sea surface? Why not over land area? Because you need moist air mass, warm and moist air mass to carry out the self intensification process that can only be generated from sea surface. Presence of Coriolis force is a must. Only then will you have a circular motion. It is because of this reason why no cyclone formation, hence, No cyclonic formation over equator. Formation over equator. Okay. Very small variation in the vertical wind speed. What do we mean by that? This is what is also referred to as wind shear. Wind shear. Now, what is this? So, let's suppose you consider the land surface, wind near or the water body, wind near the surface, and wind higher above. There will be a difference in velocity. Let's suppose this is moving at 60 km per hour. This is moving at 70 km per hour. But the difference in wind velocity should not be very high. Why? If the difference in velocity is very, very high, whatever cloud will be created will immediately be blown away by the upper wind. It will not allow for sustained cloud formation and sustained latent heat based intensification. That is why small variation in vertical wind speed. In a tornado, it is this wind shear. If this wind shear is high, a tornado can be generated. Right? In India, you generally don't have the case of tornado. Then, a pre-existing weak low pressure area, generally provided by the ITCZ, which can intensify the cyclonic circulation. So these are the necessary conditions for the cyclone formation. Now, then there is a classification of that based upon the wind speed, right? So you have the types of disturbance. So if the wind speed is less than 31 km per hour, simply a low pressure. 31 to 49, a depression. 49 to 61 km per hour, what is known as a deep depression. Okay. Then if the wind speed is between 61 to 88 km per hour, it is known as a cyclonic storm. If the wind speed is 88 to 117, severe cyclone. 117, 120, 140, 150, severe cyclone. More than 220, a super cyclone. This is very rare occurrence. Okay. Now, it is also classified as per category. Category 1, wind speed of 120 to 150. That is where the cyclonic circulation starts. Then category 2, 150 to 180. Category 3, 180 to 200. Category 4, around 200 to 50 and beyond, to 20 and beyond. Category 5. This is associated with maximum destruction. Okay. You can keep this one in mind. You don't need to ratify everything. You can just keep this one in mind so that if UPSC asks, you can have a classification. For example, UPSC had asked this particular chart in the mains exam once. That is the color coded warning. So you have the color coded warning associated with the cyclonic circulation, which is issued generally by the meteorological department. What is that? So you have the green color, right? 118 km per hour. What type of disturbance causes destruction? Destruction is created anywhere if the wind speed, let's suppose, is 120 plus. It is destructive. 220 plus is devastating. Okay. If the wind speed of 120, 130, 140, 150 plus, it can break your temporary structures, the mud houses, the thatched roofs that can be broken, right? 220 plus, even the permanent buildings, they also suffer damages. The trees will get uprooted. Those trees, the poles, electric poles, etc., get uprooted. There will be a lot of flooding of the region. That happens at around 200, 180 to 200 km per hour. Okay. Typhoon and a cyclone is just the same. There is nothing known as the typhoon cyclone. Typhoon is the cyclonic circulation which occurs in the region of South China Sea and Western Pacific. Cyclone is the occurrence which occurs in Northern Indian Ocean. Both are the same. There is nothing known as, do you hear about hurricane typhoon? No. Do you hear about the case of cyclone, hurricane? No, they are one and the same. Okay, I hope you understand that difference, right? Now, this is the color coded warning issued by the meteorological department. So, green color, no severe weather expected, around 100-kilometer winds. Then you have the yellow alert, you have to be aware. Then, after that, orange alert, where you have to be prepared that there can be damage. Red alert, generally issued in category 4 and category 5 cyclones. That means damage and destruction is imminent. Now, cyclone, one of the impact that it causes is the storm surge, the coastal flooding. Okay. So during the cyclone, what happens? Winds are very, very strong, high velocity winds. These winds are able to drag greater amount of sea water, generate very large waves, and create this coastal flooding. That is why when cyclones hit, let's suppose Tamil Nadu, Odisha, Maharashtra, any of these regions, they will always end up causing coastal flooding. So, storm surges are the large waves generated whenever you have the case of a very strong cyclone. That is what is known as a storm surge. Okay. Now, coastal flooding is also associated by a few other factors. Twin cyclones not required for UPSC. So, Bhavita, there is something known as twin cyclone. There is something known as Fujiwara effect. Okay, what is a twin cyclone? Twin cyclone, you can have two simultaneous generation of cyclones at different places. It can be in the same hemisphere. It can also be in the opposing hemisphere. That is what is twin cyclone. Other aspect is Fujiwara effect. Fujiwara effect is when you have the interaction of two of the cyclonic depressions. When they collide, then what will be the outcome? They can become very large, they can divide into three or four sub-small low pressures, etc. That is what was provided by the by the meteorologist named Fujiwara. Both of them associated only with your optional, not associated with your general studies. Definitely beyond the scope of your NCRT. Okay. Now, when we talk about the case of the coastal flooding is caused because of three factors. One is the case of the storm surges, okay, means larger than normal waves, larger than normal waves. Now, for the rest two, I need you to apply your logic and understand this carefully. So, if I consider the oceanic area, now this is a region which has got atmospheric pressure acting upon it. What is the atmospheric pressure? 1013.2 millibars. That is the atmospheric pressure. That is what is maintaining the sea level. Now, when you have the case of a cyclone, cyclone means an intense low pressure, maybe around 950 millibar. So, here in this region, the pressure is less. So, do one thing, take your forearms, take four fingers, and press the four fingers on your forearm. You will observe that in between, in the gap, your skin appears to bulge. Why? Because all around that skin, your fingers are pressing. But then in the gap, there is no pressing factor, which creates a bulge. So here, when you have the low pressure, enough pressure is not acting on the surface. Means what? There will be a bulge, a temporary bulge of seawater, temporary rise in seawater. Why is this temporary rise in seawater or in sea level? Because of intense low pressure. As the entire system moves towards the land, this risen seawater also comes to the land and causes flooding of the coastline. Okay? But many of the times you observe, for example, in the river valley, you have regions such as which are, let's suppose, 100 kilometers from the coastline, 150 kilometers from the coastline. Even those areas get flooded. How? So, here again, understand the logic. Now, basically, when you consider the rivers, right? Now, these logics you will not find in your NCRTs. You will not find in the many of the reference books also. This is from the meteorological website and the research papers. Please pay attention to this. Not to be found in many of the lectures by educators also. So please pay attention. This will add point and diversity to your mains answer and provide an edge from your competitors who will restrict their answer only to surges. That is my guarantee. Now, when you consider the rivers in any particular area, the rivers, when they empty themselves into the sea, okay, so basically, the rivers will empty all their water into the sea. They generally follow a kind of a gradient and they flow into the sea. What if the sea level has risen in this region? Will the river water be able to flow towards the sea anymore? No, the sea is blocked because the sea level has risen. So, all that liters and millions of liters of water that the river is carrying on an hourly basis is not able to empty itself anymore because the sea level is high. So, what will happen? The river will start to overflow across the entirety of the river channel. That is where you have the flooding of the rivers, of the rivers due to blockage of exit. Why is there a blockage of the exit point? Due to the temporary rise in the sea level. So these three factors will end up creating flooding whenever a cyclone makes a landfall. Okay. Now, another aspect, that is why wind shear is high in Arabian Sea, not in Bay of Bengal. No, wind shear can be high anywhere. Wind shear can be high even over the land areas. Many of the devastating cyclones of Bay of Bengal, they are, so for a cyclone to get created, you need a low wind shear. Okay, so it is not necessary that always the wind shear is very high. For example, during cyclone Tote, wind shear was very low. Wind shear is impacted by multiple factors. One is the case of the gradient of pressure in vertical height also. There is a gradient of pressure in horizontal aspect. There is a gradient of pressure vertically as well. For example, on the surface, you can have high pressure, low pressure, etc. At a height of 2 kilometers also, you will have high pressure, low pressure, etc. At a height of 4 kilometers also, you will have. So that generates multi-level wind systems, right? So these multi-level wind systems, depending upon the pressure gradient, generate a wind shear. So it is always going to be dependent upon where the wind is originating and what is the conditionality of heat produced at higher atmosphere. So the conclusion is absolutely incorrect that wind shear is always going to be high in the region of Arabian Sea. In many of the cases, wind shear can be very low as well. We have seen that in the case of cyclone Tote. Okay. Now, most of you basically have the case of where you are trying to find the answer of why Bay of Bengal experiences more cyclone as compared to Arabian Sea. I can figure out by the questions that you are trying to find the answer to that question. That why Bay of Bengal experiences more cyclone as compared to Arabian Sea, isn't it? The reasons are multifold. There is not one answer to that. For example, depending upon the size, Arabian Sea is much larger, Bay of Bengal is much smaller, surrounded by by land areas from very close quarter, due to which the heating of Bay of Bengal is much higher. It is also the bathymetric, that is the depth of the Bay of Bengal. Depth of the Bay of Bengal, some shallow regions, particularly associated with the coastal area, ensures that there is subsequent heating. Then the continuity of water body all the way from the region of the Andaman Sea many of the times ensures that low pressure system travels from the region of South China Sea into the region of Andaman Sea as well. Other than that, you have the atmospheric conditions such as ENSO circulation, Walker circulation, Indian Ocean dipole. So, under natural circumstances of Indian Ocean dipole and ENSO circulations, Bay of Bengal will favor more low pressure generation. Then, other than that, there is an oceanographic factor as well. That is basically the influx of freshwater system in the region of Bay of Bengal allows for easy stratification of water. That is basically why immense heating happens in a short duration. But all those details are beyond the scope of your NCRT, and that is where we will not delve into those details right now. This is just for the NCRT. Already, naming of the cyclones is something we are exploring beyond the NCRT. For those details, join the plus classes and we will cover it in as detailed manner as you can think about. Now, here, basically, how is it that the cyclones are named? Sir, please repeat temporary rise. Temporary rise in the sea level. Very simple. Let's suppose this is your sea level. Every place is experiencing atmospheric pressure. Atmospheric pressure is how much? 1013.2 millibar. When will a cyclone get created? When you have a low pressure, means they I am pressing this with a lower pressure. If I'm pressing this portion with a lower pressure, means what? There will be a bulge which will be created. So that bulge in the sea is basically seawater going up. Even in this image, the schematic image that I had indicated, observe the background image here. Observe the background image. Are you able to see the bulge at the center? That is because of the low pressure. There is not enough pressure pressing it everywhere. That is why there is a kind of a rise. Okay. Now, after this, the naming of the cyclones. Now, when we talk about the case of the naming of cyclones, this is quite a new phenomenon. You see, in the early 1900s, the naming was very random, very randomized. For example, a cyclone which would hit a boat, destroy a boat named Antia would be named as a cyclone Antia. Now, in the region of Atlantic, naming did start after the Second World War. Now, in those days, what would happen is that basically the geographers, the climatologists, they named the cyclone after their wives or some of the girlfriends or some of their feminine friends that they would know. So, and it would follow alphabetical order. For example, the first cyclone of the year would be named somewhat like an Amanda or an Annie. The second cyclone, Betty. Like that, you would have third cyclone, a Catherine. Like that, there would be feminine names which would be given to the cyclone. The story would go that because it is the case that many of the you have the famous saying, hell hath no fury like a woman scorned, right? So the devastating nature was associated with the feminine nature of it. Obviously, that created a lot of backlash. So from the 1970 onwards, 1980 in fact, 1978-79 onwards, you had even the masculine names which were provided to the cyclones in the region of the Atlantic. The hurricanes were provided with this name. In northern Indian Ocean, you still did not have the naming which was done. There was one cyclone which changed everything. And that was the year 1999. Many of you might not even have been born at that point of time. 1999. Now, in 1999, you had the case. Now, do not think that 1999 India was the same as today's India. You only had a dominance of kacha houses, mud houses, thatched roof, etc., for kilometers together. Pakka houses in many of the districts would be a rare aspect, a rare occurrence. Now, in 1999, the meteorologists detected formation of a very severe super cyclone in the Bay of Bengal coastline, which was expected to hit Odisha. Now, the government obviously tried to announce it, but then the government announcement in 1999, not everybody, nobody had cell phone. Very rare people, a number of people had cell phone. Public announcement system was not so good. So the announcement was very restricted. In many districts of Odisha, some of the district collectors went door to door to talk about the evacuation of houses. But people don't trust the government. If today someone from the government comes and tells you that evacuate your house can get damaged, the suspicion will be that this individual wants to live in my house. That is why they are asking us to move out. So imagine the suspicion in the 1990s. It was at peak, very high. So people did not evacuate. The cyclone hit Odisha coastline, the region of Cuttack, the region around entire coastline from Puri, Cuttack, everywhere. It was devastated. The region was flooded, right? Loss of life and property was countless. It is this moment that many of the politicians who now retired, they have written in their autobiographies as well. Now, people were shocked. In recent times, they had not experienced such a devastating loss of life and property. Now, when you face this setback, who will you be angry upon? Will you be angry upon yourself that the government came to tell us, but then we did not vacate our house? No. You can never be angry on oneself. So people became angry on the government. That look, you should have forced us. You could have announced it better. You could have communicated better, and then we would have evacuated maybe easily. So they placed the fault at the doorsteps of the government. Now, within the next week, another super cyclone started developing in the same region of Bay of Bengal, again expected to hit Odisha. This time, now there was only a gap of 1 week. This time, the government was on its toes. Government went from pillar to post to announce that another cyclone is coming. A cyclone is going to hit the region of Odisha. Please evacuate. Please take shelter. But what was the perception that the population had? That look at these fellows, pathetic people. The cyclone has come, killed our young loved ones, and now they are coming to announce. It is a typical case of delayed government announcement. Many people did not vacate their home. And while they were out there in the flooded streets, in the flooded region, to search for their loved ones, to gather their lost property, that is when the second cyclone hit with all its fury. That is where the total death toll is expected to have crossed more than 10 to 15,000. This is where you had the famous account by the previous Congress minister, Ghulam Nabi Azad. He recounts of basically visiting those flooded streets with dead bodies floating around. And he broke down, even recounting that story in the parliament. You had dead bodies everywhere. Imagine more than 10,000 to 12,000 people dead. Now, what was the learning from this? The learning was, first of all, get your disaster relief operations in order. And secondly, communication needs to be better. Rather than saying a cyclone is going to hit, a cyclone is going to hit, why can't we say a cyclone A has hit, now a cyclone B is coming? That is where the case of the naming of the cyclone started gaining prominence even in northern Indian Ocean. It is at that point of time when in the year 2000 you had a meeting in Muscat of World Meteorological Organization and ESCAP under UNESCAP. Now there 8 countries of the northern Indian Ocean, they came together, right? And they agreed, including India, Pakistan, Bangladesh, Sri Lanka, Thailand, all of them, they came together. Now, all of them felt the need to provide the names. So, each of these 8 countries provided 8 names. In total, how many names do you have? You have 64 names. Now, there was some kind of decorum which was maintained. Political name should not be given. No name should be given, which is very difficult. Right. It should not be a name. For example, if Shashi Tharoor gives a name, half the world will find difficulty in even pronouncing that name. So the name should be easy, easy to pronounce, no particular damage or to the sentiments, right? The religious cultural sentiment should not be hurt by these. So, like that, 64 names were provided. One by one, all the names were given to the cyclones. This naming started in 2004. Okay. And after that, for the next year, for the next few years, the names were given. This list got over in 2019. So in 2019 itself, again the countries of Northern Indian Ocean got together. But this time you had 13 countries. All of them provided 13 names. So in total, you have how much? 169 names. The cyclones in the northern Indian Ocean are being named from this list of 169 names. So, how is it, first of all, that the naming is done? So, across the world, you have separate areas which are known as regional specialized meteorological centers. You have 6 such regional specialized meteorological centers monitoring different parts of the oceans of the world. So, first of all, whenever a low pressure is created, the tropical cyclone warning centers, they get to know, they observe that low pressure center with the help of the satellite imagery and the sea based observatories. Once they are sure that this low pressure can develop into a cyclone, then they pass that message to that regional specialized meteorological centers. Now, these are your regional specialized meteorological centers of the world. For example, for any hurricane occurring in the region of Atlantic, naming will be done by RSMC Miami in Florida. Any hurricane which occurs in the region of Eastern Pacific, naming will be done by RSMC Honolulu. Any kind of cyclone in Southern Pacific, RSMC Nandi. Any typhoon which develops in Western Pacific, monitored and named by RSMC Tokyo. Any cyclone occur or willy willy in southern Indian Ocean, RSMC Reunion, which is basically governed by the French Meteorological Department. Any cyclone in northern Indian Ocean, be it Arabian Sea or Bay of Bengal, RSMC New Delhi, which is in the same building as the Indian Meteorological Department. They pick the name from the list and they name it. What is the list? This is the list. Okay. So here, for example, the countries are arranged in an alphabetical manner, the 13 countries. And the name given by them is arranged in the row in front of them. The naming is done like this: first, second, third, fourth, fifth, sixth, like that. Now, basically, you would have observed that you had the cyclone Murasu, which has occurred. Next cyclone, whether it will occur in Arabian Sea, Bay of Bengal, Akwan. Next cyclone, which will occur either in Arabian Sea or Bay of Bengal, Kani. Next cyclone, Nagaman. Like that, the naming will be done till you have 169. Once the name appears to get over, the members will meet again and will generate a new list. Okay, so these are your 13 countries, and this is the 13 name provided by all of them. Do you need to learn this list? Anybody who tells you or gives you such kind of recommendation, stop following them from that day itself. Learning of the names is not at all important. UPSC in the mains examination has asked how the naming is done. Now you know the detailed story. Okay, so that basically is the case of the cyclonic circulation. Oftentimes you can observe that two cyclonic circulations can occur simultaneously. Two such low pressures can get created simultaneously across both Arabian Sea and Bay of Bengal. When we cover the portion of Indian geography and Indian monsoon, that is when we will touch back upon this to understand the cyclonic seasons of India. This is as detailed analysis and as detailed a coverage of tropical cyclone as is required for your examination. I hope from the very initial portion to now, you have understood the entirety of the case of the tropical cyclone formation, intensification, dissipation, why it is known as a heat engine, the reasons why it can create coastal flooding, the factors associated with the cyclone, then the conditions necessary for a tropical cyclone, also the case of the naming of the tropical cyclone. That is more than sufficient even for your optional exam if you are preparing for your optional paper also. If you have gained from this, if you have liked the session, bless us with a click on your like button. Share it with your friends. Let them know what a tropical cyclone is and how it is to be dealt with. It should never be restricted only to the surface, as is done in many books and by many educators. You need to know the conceptual clarity. So share it with your friends. Subscribe to the channel if you have not already. And we meet again tomorrow. First of all, in this world mapping session, join us with the scan code that I have shown to you in the first part of the class itself. And tomorrow, in the evening at 7 p.m., we continue with the discussion of cloud formation. What are the different types of clouds? Why do you have thunder and lightning which is experienced? Why many of the times you see a cloud, but it doesn't rain? That is something that we are going to cover tomorrow. So take care of yourself. Stay happy. See you tomorrow. Goodbye. Thank you.